Hi everyone, this is TA William, and this is the recorded video of our Week 2's TA class. And in this week, the video will be recorded by me and by TA Chiyo, and this is the part of my video. So today I'm talking about infinite limits and also about another important theorem, which is called squeeze theorem. Okay, so let's get started. So the first part will be the vertical asymptotes. In Chinese, it will call it 垂直渐近线. Okay, so if you want to know the Chinese, it will be 垂直渐近线. Okay, so by definition, we say that we have a function f of x, and the limitation of the function f when x approach to a, if it equal to positive or negative infinity, then we say that x equal to a is the vertical asymptotes of the function f of x. So in another way, we can say that the limitation of function f of x when x approach to a plus is positive or negative infinity, and when our limitation of our function f of x when x approach to a minus is also positive or negative infinity. Okay, so when we look at this picture, this graph, so the green graph means that when the graph from the right hand side, it is like a straight line, and it will be no value in the point. Let's say in here is x equal to 2, but in the left hand side, you'll see that when your graph approach to x equal to 2, it goes to positive infinity. So in this case, we can say that x equal to 2 is the vertical asymptote, okay, of this graph. Okay, so we have the vertical one, we also have the horizontal one. So similarly, the definition will be the line y equal to L. So now it's a horizontal line. We say y equal to L is a horizontal asymptote of our f of x if our limitation of our function f when x approach to infinity or minus infinity will equal to a number L. Okay, so it will not be infinity, it will be a number we know. So again, we look at the graph. Let's say the green, this function is oscillating from x in the minus infinity way. So it's just oscillating and all the way to a positive infinity. It be infinity approach to a line. Let's say this is y equal to 1. So in this case, we will say that our y equal to 1 is the horizontal asymptote. Okay? And the third is the limits at infinity. So just as you know that we have to do a many limitation of when x approach to some value of a. So now we change the value of a into infinity, so it will become the limits at infinity. So we will say the limitation of f of x when x approach to infinity will equal to L if the value of x get arbitrarily close. Okay, so it can be arbitrarily close to L. Okay, so let me draw it again. Arbitrarily close to L when our x is sufficiently large positively. So this is the same meaning. Sufficiently large positive, it just means positive infinity, and another way is negative infinity. Okay, so this is the same definition. Okay, so now we know the definition, we know how it works. Now we do some example. Okay, so the first one is we want to find the asymptosis of the function f of x equal to the square root of 4x squared plus 5 over x minus 3. Okay, so make sure that when the question asks asymptosis, in here means your horizontal one plus your vertical one. Okay, so don't forget to count the both. Okay, so we look at the function. Our f of x will equal to square root of 4x squared plus 5 over x minus 3. So in this case, what we want to do is first take our x out, because we want to make our numerator and denominator have the same power of x. Okay, so make sure that every time you take the x squared out of the square root, it will equal to the absolute value of x. Okay, so in this case, we will get 4 plus 5 over x squared. And in the denominator, it will be just x minus 3. Okay, so now we first find the horizontal one. Okay, so we start from the horizontal one. Let me change the color, horizontal one. Okay, so we first try when our x approach positive infinity. So in this case, that when the limitation of the function, let's say this function, and we know that since this part, our 5 over infinity squared will equal to 0, will approach 0 when our x approach infinity, right? So it will becomes limitation of our x approach to infinity, you get 2, because you get square root of 4. 2 is 2 times the absolute value of x over x minus 3. And we know that when x approach to infinity, our minus 3 can also be ignored. Okay, so at the end will be 2. Okay, you can ignore this one when your x is infinitely large. So this can be ignored. Okay, and second one, we want to know when our x approach minus infinity. So we take our x to minus infinity as the same way. And similarly, this one can also approach to 0, right? And because you have the absolute value here, so this will become kind of a positive infinity. And this will also be minus infinity. So at the end, you'll get the minus 2. Okay, so combining these two results, we know that y equal to 2 and y equal to minus 2 is our horizontal asymptotes. Okay, our horizontal asymptotes. Okay, so next we check out the vertical one. So the vertical one, where should we start? So the most simplest way to see is we want to make our f of x go to positive infinity or minus infinity. So when we have a fraction, we want to make our denominator go to 0. We want to make this go to 0, so our f of x will explode to infinity or minus infinity. So we try x equal to 3 positive, and we know that it will equal to our f of x will explode to positive infinity. Okay, because all the number is positive, and because your x minus 3 is greater than 0, right? And the other way, when our x approach to 3 minus, it will approach to our f of x will explode to minus infinity, since our x minus 3 was smaller than 0. Okay, so this is relatively simple. So we know that x equal to 3 is the vertical asymptote. Okay, so this is part of the infinite limit. Okay, so second, the example 2. So it now want us to compute the limitation of x plus square root of x squared plus 2x when our x approach to minus infinity. Okay, so you can first just plug in your minus infinity into it, see if you can find out any value of the limitation. So when we just plug in, so now assume that we don't know how to do it, we just plug in. So you get a minus infinity plus, you get infinity squared plus 2 infinity square root. And you can see this as infinity. So actually you don't know what the value is, right? It will not be 0, okay? This will not be 0. So we don't know the value of it. So we need to derive a way to do this. And when you see, there's a note here, is when you see a polynomial, you see a polynomial, 中文多项式. When you see a polynomial plus or minus a square root, you need to think of rationalize, okay? Okay, so this is a really important skill in doing limitation. Okay, so now we try to do rationalization. So we times x minus the square root on the denominator and denominator. X squared plus 2x. Okay. So now it will equal to our limitation, x approach to minus infinity. And then above you will get x squared minus x squared plus 2x over x minus square root of x squared plus 2x. Okay, so obviously you can get this two term divided, and you will get minus 2x in the top. You get x minus the square root. Okay, so how do we do? We now change to a form which is relatively solvable, you can say that, but how to solve it? So now we know that there's a square root here, right? Here's a square root. So we want to take it out. Every time we do in the last part of the limitation, when there's a square root, we want to take it out. But make sure that in this case, your x squared in the square root will equal to what? The absolute value of x actually is the minus absolute value of x, right? Because your x is minus, is smaller than 0, so this one is greater than 0. Everything come out from the square root is greater than 0. But you actually have, like this, minus x, not absolute value of x, minus x, okay? So, because your x is smaller than 0, so you need to add a minus sign in here. So make sure that you notice this one. And we take it out. So now we take it out, 1 plus. Okay, so this one is plus, okay? You change from minus to plus. And at the end, you'll get minus 1. Because this term go to 0. Okay, so you get minus 1. Okay, so make sure that this part, don't mess up with this one. Okay. Okay, so now we start from example 3. So it wants a limitation of sine with 1 over x minus square root of x squared plus 1 when our x approach to infinity. Okay, so I forgot to say, if I recommend all of you to first, if you want to try to do it yourself, you can just pause the video and try to do it yourself before I explain it, and it will be a great practice for all of you. Okay. Okay, let's see. So how do we do this? So what we see is x minus square root of something, right? So it's the same note in here. If we don't know, if we just plug in, we cannot get any answer. We just try the rationalization. Okay, so we try rationalization. So our limitation, x approach to infinity. And what we get is sine x. So we just take this sign out, and we get this one. And okay, so we rationalize it. Rationalize. And what we get is limitation when x approach to infinity with a sine 1 over x. And what? And we get, let me see, x plus, we get x squared minus x squared plus 1, so we get minus 1 here. Right. Okay. And so what should we do now? If you now plug in, you will see that this sine, you can say 0, it will be 0. And you times infinity. So we actually don't know what it goes. So what we think about is, another important skill in here is when you see sine 1 over x, and when your x is go to infinity, you can think of sine y when our y go to 0, right? Because we can replace our x with y equal to 1 over x. So our y will equal to 0 when our x go to infinity. And we also notice what? When our limitation x equal to 0 when sine x over x. When our x approach to 0, you get 1, right? This is proven in the video, in the lecture. So this is very, very important. Okay, so this limitation, you don't need to prove in the test or in the exam. So this is just like, you can just write that this one equal to 1. This limitation equal to 1 when you are in the quiz or the homework or in the final exam. Okay. So what we first take out is we make a 1 over x in the denominator. Okay, so here's a minus 1 here, and I get 1 plus, right? Okay, so this is what I got. And by using this one and this one, we can turn, let's say, our y equal to x over 1 over x. So we get a y equal to 0 plus, and our sine y over y, right? And a minus 1 times 1 plus square root of 1 plus y squared. Okay, so you can plug in this one into here. you'll get this equal to 1 times minus 1 times 2. Right. Okay, so the answer will be minus 2. Okay, so the point of this question is, the first one is to rationalize. Okay, so this is same as the example 2. And the other one is when you see sine 1 over x and your x is equal to infinity, you should think of this way. You can substitute your x with your y, and your y will equal to 1 over x. And at the end, you use the very important limitation, the limitation of sine x over x when x approaches 0 will equal to 1. Okay, so this is very important. Okay, so all the first part of the infinite limit will be finished, and the second part is another very important theorem when you're doing limitation, is a squeeze theorem, which is also called sandwich theorem, I guess. So let's also start from the definition. So suppose there are 3 functions. We say there are f of x, g of x, and h of x. And we know that, assume that we know that f of x is smaller or equal to g of x, and our g of x is smaller or equal to h of x. Okay? So under this situation, if our limitation of f of x and our limitation of h of x when our x approach to a are same and is infinite, which means it will equal to some value of L. Then we say the limitation of our g of x, which is in the middle of the 2 function, will also be L. Okay, so when you're looking at the theorem itself, it will be like relatively straightforward. But this is a really important theorem when you are doing the limitation in the test or in the quiz. Okay, and another important skill with the squeeze theorem is that when you see the sine and cosine, okay, when you see sine and cosine, always remember that sine of x was between 1 and minus 1, and also cosine x is between 1 and minus 1. Okay, this is very important because this is one of the bounded solution you can use in the squeeze theorem. Okay, sine and cosine, 2 important function. Okay, so let's now look at example 4. We want to find the limitation of these whole when our x equal to infinity. Okay, so you can stop from here if you have any idea, and you can later see how do I solve this question. So how do we solve this actually? Okay, so as now we are talking about squeeze theorem, we want to implement the idea of squeeze into this question. So first we look at this 3 term, 2, 3, and 5. So we know that these are the smallest term in the parentheses, right? And the 5 are the biggest term. So which means the lower limit, let's say the f of x is our lower limit, will be our 2 with the x power. And our maximum limit will be our 5 with the x power. Something related to 5 with the x power, right? So what we know is that when we get these 2, if we get our 2 and 3 out, if we get these 2 terms out, it will be definitely smaller than this term, right? Because we are in the positive power. Okay, so notice that this is the positive power. Positive power. Okay, so when we get 2 and 3 out, it will be definitely smaller than this whole numbers. Okay, so our lower limit will be our 5 with the x power with 1 over x power. Okay, and the up and in the middle is what we want to find out, this ugly term. Okay, so And what is the upper limit? So in the upper limit, we want to, because we know that the biggest term is 5. So what we do is we change our 2 and 3 all into 5. Okay? So our idea is change all of them into 5 with x power. Okay? So this will definitely be greater and equal to the ugly term, right? So now we have the lower limit. We have our, let's say, lower limit. Lower bounded. Okay, let's say lower bound. Lower boundary and our upper boundary. Okay, so now we apply the idea of squeeze theorem. So we find the limitation of this two term. Okay, so the limits are of our list 5x with 1 over x power, which is 5. Right? So this is straightforward. And this one, the limitation of our 3 times 5 with x power over 1 over x power. So what will this be? So this will be, you can take this two term out. So 1 with 1 over x power and times 5. And we know that this will approach to 0, and anything with 0 power will equal to 1. So it will become 5. Okay, so from our list 2 answer, we know that the answer is 5 by squeeze theorem. Okay? By squeeze theorem, we know that the answer, because you get 5 here. You get 5 here, you get 5 here. So this limitation will also be 5. Okay? So the next one, example 5. The module want us to find out the limitation of x minus cosine x over x plus cosine x when our x approach to infinity. Okay, so what I say before is what? When you see sine and cosine, you think of this one. So in this idea, how do I implement it? So my what I do is I subtract both my denominator and numerator with x. So it'll be 1 with cosine x over x and 1 plus cosine x over x. Okay, so now we focus on this term. We only focus on this term. So cosine x over x. Okay, we know that cosine is between 1 and minus 1, right? So it will definitely be smaller or equal to 1 over x and greater and equal to minus 1 over x. Okay, so we apply our squeeze theorem and compute the limitation of our upper bound and lower bound. So, because now our x to infinity is 0, and also the other limitations is 0. Okay, so we know that by 1 and 2, and using squeeze theorem, we know that limitation of cosine x over x when our x approach to infinity is 0. Okay, so we know that this term is 0. The limitation of this term is 0. So we just plug it inside, so we know that it will become 1 minus 0 over 1 plus 0. So it will equal to 0. It will equal to 1. Okay, so this is the answer. And this is also the answer. Okay, so the idea of this one is when you see cosine and sine, you can try the way of using the characteristic of sine and cosine between 1 and -1. Okay, so the last two example, we want to find out the limitation of this whole stuff of ugly number. So when you see this, don't be shocked by that. Oh, there's so many sine term and there's a I don't know what this is, the absolute value, 1 over absolute value. So don't be shocked by this one. Okay, so just keep in mind that anything inside the sign doesn't matter because you are be blocked by a sign. So this whole term will be bounded, right? So okay, so which means that any term inside this isn't important. Okay, so in this case, we just apply again sine. Inside the sign is also a sign with 1 over absolute value of x. No matter what inside this, it will be between the 1 and -1. So what we want to compute is x with 1 over 3 power and the positive one. Absolute value of x was 1 over 3 because we don't know if x is positive or negative. So in this case, we add the absolute value and plus a minus and positive sign. Okay, so now our things to do is to compute the limit of this two. Okay, so first do the first one, the limitation of minus absolute value of x with 1 over 3 power and minus. So this is relatively straightforward. So this two will be the same. Will both equal to 0. So by squeeze theorem. So let me mention that in the test or in your homework, I hope you to add this word by squeeze theorem because in the final exam we want to know that what did you apply and I want to know if you know how to use this theorem and when do you use this theorem. Okay, so you need to write this down in the final exam. So by the squeeze theorem, we know that the limitation of this whole stuff sine equal to 0. Okay, so the answer is like this, and just make sure that you need to write down when do you apply the theorem and what theorem do you apply. Okay, so the last example, also a limitation with sine 1 over x. Okay, so now when you see sine 1 over x, you know what to do, right? And you see x goes to infinity. So what we do is we substitute our x with y, and our y will equal to 1 over x. Okay, so in this case, look. Okay, so our limitation, y go to 0 plus, right? Because we are now positive infinity. 0 plus, and let me see, 2 square root of 2 over y plus y squared plus 1 and sine y. Okay, so you want to make a sine y over y, right? So you take your y out. 2 plus y squared sine y over y. Hope I'm doing right. Yes, I think. Okay, so, and we know that this will equal to 1, right? So the answer will be square root of 2. Check. Square root of 2. I'm doing right, and okay. Okay, just checking if I'm doing all the example right. Okay, so the last is the note of doing limitation. When you're doing limitation, there's 4 points you can notice. The first one is what I mentioned in example 3 and 4. 2 and 3 is irrational, okay? And the second one is the squeeze theorem. Okay, so it is a very powerful theorem when you are doing the limitation. And the third one is one of the most important limitation, sine x over x equal to 1. And number 4 is what you haven't learned is L'Hopital rule, but you cannot use now, but later you will learn in the class after this. So in Chinese is 罗必达. Okay, so these are 4 important skills you need to use or you need to notice when you are doing limitation. Okay, so I think this is the whole video section of mine, and if you have any question you can email me by b08502022 and to. Okay, so if you have any question you can email me if you find out there's any problem in this video or any part you cannot realize in this video. Okay, so see you, hope to see you guys in the physical lecture in the 4th week. Okay.